All right, 7.1, solve linear systems. By graphing. So this is why I said you're going to want graph paper, because just to give you kind of the quote-unquote SparkNote version of what we're doing, basically you're going to be given two equations of lines and you are going to graph them on one graph together, and the point where they intersect is the solution to both equations. So, a couple definitions. A system of linear equations sometimes this is also just known as a linear system. Basically, two or more linear equations in the same variables. So an example of this would be like 3x plus 2y equals 8 and x minus y equals -2. So that would be a system of linear equations, or a linear system. Now, we're right now just dealing with two equations, so I will often refer to this as two equations, two unknowns, okay, meaning we have two equations, two variables that I don't know what they are. In not this chapter, I don't even know if we do it in Algebra 1, if I'm going to be completely honest, but if we don't do it in this year, you definitely will in Algebra 2, but we solve three equations with three unknowns, meaning three equations and they have three variables in them, but that's much harder. We'll be thankful that we're just dealing with two for right now, because everyone always hates three equations with three unknowns. Anyways, then the other definition that we need to be aware of is the solution of a system of linear equations. Which is basically just an ordered pair that satisfies the equation in each system. So it'll be an XY ordered pair that solves it. And so we have many different methods that we can use to solve a system of equations. As you can probably infer by the title of this section, the first method we use is by graphing, which in my opinion is the hardest one. Okay, and I say that because if you can't graph a line, you probably can't graph two, meaning you can't find the solution. But the good thing is there's a method to check so that you know if your answer is right or wrong. So hopefully that will help you. Also, typically, when we're solving these, at least in Algebra 1, you're going to have one line like this and one line like this, okay? So one of them's got to be a positive slope and one of them has to have a negative slope, okay? So if your lines are going the same direction, at least at the beginning what we're doing, you've done something wrong. So hopefully that's another clue for you also. If your lines don't intersect somewhere, you've done something wrong, okay? Now, when we get to Algebra 2, or potentially later on in this chapter, that won't always be the case, but for what we're doing right now, they have to intersect in one spot. I forgot about this definition. A consistent, independent system is a linear system with exactly one solution. So the way I always tell people to remember this, because this will come about later on as well, is that if you're independent, you like to do things by yourself, and there's one solution. So you're doing, the solution is acting by itself. So hopefully that helps you, because we'll later on have dependent and we'll have inconsistent also. But again, not right now. This is the only option we have in this section. So don't need to worry about those yet. I think the other options come about in like the end of the chapter. So we got a little while before we have to worry about them, but all right.
Bro, come on, you understand.
Steps to graph a system of equations. Step 1, graph both systems or graph both equations on the same coordinate plane. If you try to do two separate graphs all together, they're never going to cross because there's only one thing on each one. So they both got to be on the same one. Now, if the lines are not already in slope-intercept form, or just in intercept form, but intercept form doesn't always work super well when you do these because it can cause issues if the line doesn't extend out as far as you need it to when you do that. So if they're not already in slope-intercept form, you first need to actually put them in slope-intercept form, which some of them they're going to give you already in that. Some of them you're going to have to manipulate to get y by itself. So I'm just going to make a note here. Get y by itself before graphing, aka slope intercept form. I'm shedding. Okay. Step 2 is to estimate the point of intersection. Okay, so if I've got two lines graphed, okay, then the point of intersection here is where they overlap. So we're estimating that point. The nice thing is, for the sake of this class, with the exception of it looks like one problem in the entire homework, they all come out to be nice points that are like exactly on a point, not between things where you're estimating what the fraction is and all of that. I'm going to do my best when I'm assigning problems and when I give you ones on like a quiz or a test with the graphing to give you one that intersects at a point that you can actually read what it is. Now, again, that doesn't mean I'm perfect, and that doesn't mean that I do that 100% of the time, but I do my best to give you a point of intersection that lines up where it needs to be. Again, Algebra 2 book, not quite so nice. This book seems to be pretty nice. And then step 3, check the coordinate by plugging it in to one or both equations and ensure it makes a true statement. So some of the problems may simply give you two equations and a point, and it may say to check it to verify that it is a solution, and if it's not, then you say that it's not. And then there's going to be somewhere we're actually graphing, which is why I said you're going to want graph paper. So The first thing says just to tell whether the ordered pair is a solution or not. So I'm only going to do like one or two of these because we're going to check as we go through the actual graphing problems. But number 4, they give us the point 5, 2. And then the two equations are 2x minus 3y equals 4 and 2x plus 8y equals 11. So I'm not actually graphing these points. I'm just checking. Anytime you're checking, like for step 3, once you've done this, I would use the original equation because if you've manipulated your equation wrong, okay, then you may not recognize that you did something wrong if you just plug it into your manipulated one. So I would always plug into the original to check. So first I'm going to plug it into the top one. 5 is x, 2 is y. So we've got 2 times 5 minus 3 times 2 equals 4. So I've got 10 minus 6 equals 4. 4 equals 4, so that one's good, but I've got to check it in both. Okay, for these ones, we need to check both. When you're checking a point after you've gotten it from a graph, if you're pretty confident you did it right, you only really need to check it in one. But for the sake of these ones that specifically say to check, you need to check it in both. So 2 times 5 plus 8 times 2 equals 11. 10 plus 16 equals 11. 26 equals 11, which is obviously not true, so this one is not a solution. Any questions about actually plugging them in? We've kind of done stuff like this before. We just did it with one equation instead of 2. All right. Graph and check. It says to solve the linear system by graphing and check your solution. Okay, on the quiz or the test, I may or may not require you to check it. It just depends. Read the instructions to know. But for your homework, you need to check them all. 1 for practice and 2 to make sure that you're doing it right. Okay, so if you weren't already writing on your graph paper, you definitely need to now. Y equals negative x plus 3 and y equals x plus 1. So I'm going to set up my little coordinate plane over here. All right, so the top line, and I'm going to graph my lines in 2 different colors just so we can see what's happening, but obviously y'all are supposed to be using pencil, but I just want us to be able to visualize. So what is my intercept for the top one?
-1.
That is not my intercept.
-3. We know just 3.
Positive 3. And what's the slope?
That's -1.
That's -1. That means I go down 1, right 1. And I like to go ahead and do out several points when I do this, more than just the 3, because a lot of the times it extends farther. So I like to go ahead and put some extras on the graph when I do it. Now, what is the intercept for my second line?
1.
1. And what's the slope?
1.
So it's up 1, right 1, up 1, right 1. I can already see that I've intersected, so a lot of times once you do the second one, you don't have to do as much. And so I just connect the dots there. So now my point of intersection is right here. Okay? So this point is 1, 2. Okay, so this is the point 1, 2 that I've circled. So if I've done this correctly, that's the solution to both equations. Okay? Now, when you're checking, like I said, you only need to check it in one. Do you want to check it in the top one or the bottom one?
Bottom. Top. Bottom.
Top.
Bottom, all right. So I plug in the numbers. Again, they're going into the original. So 2 equals 1 plus 1. 2 equals 2. So I've checked it and I'm good to go. 14. Y equals 2x plus 2. And y equals 4x plus 6.
You want to use two different colors for the orange lines?
No, you don't have to. I'm just doing it so y'all can see which line's which if you go back to watch this later. Because I know some people are still having trouble with graphing. So I want to make sure we know what we're doing. Now, I mean, if you want to, that's fine. If you want to use some colored pencils and do it, that's okay. But you don't have to.
I just don't like it.
I didn't say it. What am I supposed to do about fractions? They're freaky. I can't graph fractions. I just don't care enough.
If ain't nobody in the video gets it.
Should be pretty easy.
Oh yeah, I got it now.
Okay.
What's another sound?
She was not happy now. I don't think Grace.
Bud, you were just getting bullied. Stop acting like you weren't.
Weren't you just getting
No, I was not, bro. No.
All right. What's the intercept for the top one?
Two.
Don't point at me.
What's the slope for the top one?
Two.
Okay, both things are 2 in this one. So, I have a point at 2, and then I go up 2, right 1, up 2, right 1, and just a refresher, I can also go down 2, back 1. Oh, I missed. All right, now this other one, obviously I said earlier, typically we have one that has a positive slope, one that has a negative slope. Doesn't have to be that way, but their slopes obviously can't like both be the same number or it's not going to work. Because if they have the same slope, what are they?
Parallel.
Parallel lines. You'll make me happy. All right, what's the intercept for this one? 6. So 1, 2, 3, 4, 5, 6. Also, I'm going to tell you, I would not count by anything but 1 when you do these problems. Because you are going to end up getting the wrong point because your counting is going to be off and you're going to be super confused. Okay? Now, this slope is 4, but if I go up 4 and over 1, that would be way up here. Okay? That's probably not going to cross up there. So, and that's going way outside of my graph. Now, I may have drawn my graph too small. Who knows? So let's go back and down and see what happens and see if it intersects somewhere else farther back that might be more in the graph instead of starting by going way up here. Okay? So down 4, 2, 3, 4, and back 1. So I still am showing that positive slope here. Down 4 and back 1. So that kind of looks like, but again, I stopped my point. My last point I drew was here. So it's hard to say. It looks like my line's a little off. It's a possibility. But lines can only intersect in one spot, so we're going to try this. Now, obviously, I'm human, and I'm not perfect, and I didn't get out a ruler to do this. So it looks like they're intersecting pretty close to this point right here, but my lines are a little off to the side. So, like I said, with this book, they're pretty nice. They give you relatively nice numbers. It's not always the case. So, approximately, what is this point?
-2, -2.
Yep, -2, -2. And I'm going to check that. Do you have a question?
Do you have to count by ones? I got something pretty similar by counting by 2s.
Yeah, exactly.
I just said you need to count by ones.
You need to count by
You need to.
Oh, says you always are 2.
Don't lose your cool.
Because if you don't count by ones and you get it wrong, I'm going to have no sympathy because I have told you to count by ones.
No sympathy. You hear that?
I'm not going to give you something that's a ridiculous number like 26 and make you count by ones. I'm not going to do that.
No twos.
No twos.
All right, so we're checking it. Do you want to check it in the top one or the bottom one?
Top.
Top. All right, -2
Oh.
equals 2 times -2 plus 2. -2 equals -4 plus 2. -2 equals -2. So this is a solution. I did it right.
Wait, how you get all those twos?
This is why you guys have got to listen to me. The side conversations need to stop. I'm not saying you are talking, but everyone else is causing a distraction. When I'm explaining something, you are listening. If I'm talking, you are not, unless I explicitly ask you a question. This stuff is not easy. Okay? So if I tell you how to do something, I'm doing it for a reason. If we keep talking, I will stop and hand you a quiz on this stuff, and I will not teach it anymore. Got it? All right, next problem. Number 18. I'm skipping number 16 because it has weird decimal numbers as the answer. Number 18, 2x minus 3y equals -1. Now, right away, as I'm writing down this problem, I already see this is not in slope-intercept form. So I'm going to write my second equation over here to the side so I have room to work underneath so I don't have to rewrite them. Okay, but in the book, they stack them on top of each other like I have been up here. So my second equation is 5x plus 2y equals 26. Now, that is obviously a big number. So we may end up having to do something a little bit different, and I may attempt to count by twos, but I'm going to show you something different about it when we do it, okay? So I'm going to do this one as an example, but I'm typically not going to give you numbers this big on like a quiz or a test. All right. And I know that this answer comes out to be nice whole numbers. The other reason we're doing this one. All right, I need to get y by itself. How do I do that? I can't do that yet. Subtract 2x first, so I get -3y equals -2x minus 1. Now what?
Now we divide -3.
So I get y equals 2/3 x plus 1/3. So this is my new equation. Now over here, this one, how do I get y by itself over here? So I've got 2y equals -5x plus 26. Now what?
Divide by 2.
Divide by 2. So y equals -5 over 2, x plus 13. This is going to be a weird one if we try to count by twos. So we're just going to count by ones, and it's just going to be big. Just going to be the reality of it. Yeah, anyways, we have to count by ones. So, but we don't need to go up higher than 13. Again, I'm not giving you one this crazy, but you don't need to go up higher than 13. The answer's not that big. 2, 3, 4, 5, 6. And you don't really need anything in the negatives, so just like that is fine.
14.
Like I said, I'm not going to give you anything that's super crazy. This is the biggest one in this section, so we're doing it as a class. Well, I say that. I'm not giving you number 19 for homework either, because number 19 has the number 37. And it's not one that you can count by anything other than 1, because it won't work out right.
Alright, graph this.
We should count by
124.
There's just other methods that I would use other than graphing to do one that's typically this large. That's where I'm going to leave that.
Wait, is number 19
Like,
gonna be on the test?
No, she said she won't do it.
Just said I'm not going to give you one that's that obnoxiously large. If number 19's on there, this will not be the method you're using to solve it. We're going to learn 2 other methods to solve these equations like this, other than graphing, which I don't use graphing unless it says I have to use graphing. So if I tell you to choose your method, you can use graphing, but I would not. All right, so the first one, this one's a weird one, but it's 1/3 is my y-intercept. So that means I need to approximate here about 1/3. Now, my slope is 2/3. Okay, now just as a refresher, that means I go up to right 3. I don't go up 2/3. Okay, I go up 2, which would be here. So a little bit past 2 and right 3. So it'd be 1, 2, and then 1, 2, 3. So it would be right here. Okay, then I'm going to go up 2 again. 1, 2, and then right 3. 1, 2, 3. It would be over here. Now, I happen to know what the solution to this is, and that is big enough. Yeah, that's big enough. So I'm going to connect this. Whoa. The best I can. Good enough. If you want rulers when you're connecting them, if you struggle to draw a straight line, have a surplus of rulers. You're welcome to use them. All right, the next one is 13, and it has a negative slope, so I'm going to count all the way up to 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I guess I miscounted when I did my thingies.
It's so nice.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13. Okay. All right, now my slope is -5/2. That means I go down 5, right 2. Okay, because it's negative. So down 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, and then right 2. Got to keep going. Down 1, 2, 3, 4, 5, right 2. Now, I can already see that point is, at least it looks close to that line, so I'm going to assume that's going to be my point there. As soon as you see it intersect, you can stop. Obviously, on the second line, you can't stop on the first one because you've only graphed one at that point. Now, again, not perfect, but it looks like it's somewhere in this region. What does this point look like it is?
4 1/3 to 3. Oh, well, maybe not.
4, 3.
4 and
Looks.
then 3.
I'm telling you, all your answers are going to be nice, even whole numbers. Okay, whole numbers may not be. They're going to be integers because they could be negative.
Oh, 4, 4.
All right, so this is 4, 3. Now, obviously, I'm still checking it. Instructions say to check it. So, when I check, I need to use one of these original equations that I have written in black because, especially those of you that struggle with signs when you're moving stuff around, 1, it's not going to be any fun to plug in a point to something with fractions. And 2, if you struggle with signs, you're probably going to end up having something wrong, and then your whole answer might be wrong. But if you plug it into the original, you'll know either way if you're right or wrong. Okay? So I'm going to use the 2x minus 3y equals -1. So 2 times 4 minus 3 times 3 equals -1. The other thing I'm going to say when I am checking a problem, I never move things from right to left. I work all the way down on both sides. Okay, so I'm not going to move this stuff over. I leave it there. When I'm done, the left side should be equal to -1. So 2 times 4 is 8, minus 3 times 3 is 9. 8 minus 9 is -1 equals -1. So I know that that point is correct.
Bruh.
Start dragging.
Okay.
it.
Oh, neighbor. Yeah, that was not necessary. Dude, not even I seen that bad.
Yes, you do, bro.
No, no.
Your singing is heart
Are you?
aching.
You're singing it's hard.
Well, it's hard to write if my heart's already crying how bad it is.
Sing Lady Gaga.
No.
All right, number 20. This one's going to be another one that's a little bit big, but it's not bigger than this one, so it's fine. 20. 7x plus 5y equals negative 3. So again, I see that I'm going to have to manipulate this. So I'm going to write them side by side instead of on top of each other. Negative 9x plus y equals negative 11. So in the first equation, how do I get y by itself?
We subtract 7.
5y equals negative 7x minus 3. Then what?
Divide by 5.
Divide by 5. So y equals negative 7 over 5. X minus 3 over 5. So that's kind of another weird fraction. That's why I chose this one, so we can talk about that. I trust that y'all can graph things that are whole numbers. All right. Second equation. I need to get y by itself. What do I do? Add 9x. So y equals 9x minus 11. So other reason I chose this one was I noticed right off the bat that this one was going to be in the bottom. All the other ones that we've done have been in the top so far. I mean, the solution here was obviously down in the negatives, but I noticed that the graph was predominantly in the top of the other ones. This one will predominantly be in the bottom. So I need to go down to negative 11 with this one. So I don't really know. I don't know why I just made that really wide. Just go there. I don't really know how far up this one's going to go, so I'm going a lot farther. I'm giving more space up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, almost there. Now, I could be wrong. I also could need to go farther down than I went with this one, but I'm really hoping that I don't. All right, so the first line is we have an intercept of negative 3/5, so that means that it is a little bit before 1. So now I need to go down 7. So remember, when I'm counting this, I'm not going quite to the next line. It's the same amount of space here, but I've got to go down 7 and then write 5. And I may or may not do more than 2 points just because this one is super big. We'll see. So down 7. 1, 2, 3, 4, 5, 6, 7. Write 5. 1, 2, 3, 4, 5. So I'm just going to do the 2 points on this one because this one's really large. And if I need to go back and fix it, I'll go back and fix it. On the next one, negative 11. So I already counted. This one's all the way down here. This one has a slope of 9, so this is up 9, right 1. 2, 3, 4, 5, 6, 7, 8, 9, right 1. And I don't really need to keep going again. This one is super big. It looks like it intersects there, but it looks like my line's a little bit off, so I'm still going to try it. All right, so what does this point look like it is?
1, negative 2.
1, negative 2. So I'm going to check that. You want to check it in the first one or the second one? Second one.
First.
I heard
I did
second.
negatives first.
I heard the second one first, so we're doing that one. Negative 9 times 1 plus negative 2 equals negative 11. Negative 9 minus 2 equals negative 11. Negative 11 equals negative 11. So we're good. All right, any questions on these?
Nope.
All right, I want you to try some, and then we can go over tomorrow and make sure that you've got them all, down. let's see. 13. Oh, wait, I forgot. Hold on. 5, then 13.
That sounds better, but jump.
15. 21 and 23. It looks like 23 should be the biggest one that you have. Okay.
I heard about one.
So-
is there more of this lesson?
Huh?
Is there more of this lesson?
Nope, this is it.
I love my graph paper.
All right, you should be working on these. We have 10 minutes left. You should be able to get through at least one or two of them.
I do have birthday too.
For one.
Obviously, if you